so for number 9, what we got to do first is identify our u. Which one is going to be u? Now, this one's kind of hard because remember my strategy I gave to you guys was which one is the most inside function. Now, both of these are inside. Here, let me rewrite it really quick. We have the integral from 0 to pi over 4. I mean, half of calculus is just being able to read it. This is tangent theta raised to the third power. And then secant theta raised to the second. I don't know why, but that makes it so much easier for me to read. I don't know why it does, though. Okay, so now let's think about this. If I make u equal tangent, and I take the derivative of tangent, what would you get? What would you get if you take derivative of tangent? No, you don't get cotangent. Come on. Yes, you get secant squared. Okay, and since we have a secant squared right here, that would be a good idea, wouldn't it? It'd be a good idea to do tangent. If I did secant, do you guys know what the derivative of secant is?
No.
Well, that one's secant tangent. So would secant work also?
Yeah.
I don't know, maybe.
Not as much.
Yeah, it doesn't seem to be as clean. Like maybe it'll work, but I'm gonna go with the clean one. So let's do tangent. So tangent theta. Okay, so the derivative of that would be du equals secant squared theta d theta. All right, now I have to substitute stuff in. Now I see tangent theta right here. I'm gonna take.
Is just tangent theta or tangent cube theta?
Well, it's tangent cube theta, but I put the 3 out here to help us see just tangent. I'm going to take this out, and I'm going to put a u right there. And then guess what? Actually, it's this whole thing. You guys see this whole thing right here? Secant squared theta, d theta? Yeah. So that whole thing gets taken out, and we're going to put a du right there. So this is how it looks now. Now I'm choosing not to write my lower and upper bounds because they're not u's. They're thetas. Okay, now my integral has u's only. It has no thetas. These two numbers are thetas. So I'm not going to write them yet. Okay, I need to remind myself not to use these numbers. So now I do my business. I do my antiderivative, and I get u to the 4th divided by 4, or times 1/4. And then right here, I'm supposed to write my lower and upper bounds. Now, remember last time I told you guys, we have two choices. We can either sub u back in, like we can put tangent in there, or we can plug our two bounds into the u function, the u equation, and find new ones right here. I kind of want to do that because it seems like less writing. So let's do that really quickly. Let's go tangent of pi over 4. Now, I don't know if you guys remember this, but if I go to my unit circle and I go to pi over 4, which is right here, this is pi over 4. Do you guys remember what the coordinates are right there? Rad 2 over 2 and rad 2 over 2. So if I go y divided by x, what do you get? You get uno.
Uno.
Okay, now what about 0? If I have tangent of 0, do you guys remember what the coordinates are at 0? 1, 0. That's right. So, no, it's not. Now, if I take the y and divide it by 1, what is 0 divided by 1? That is 0. So we get 1 and 0. So that's what we're plugging in. Hey, that doesn't look that bad. 1 over 4. Now I'm plugging in 1 raised to the 4th power, which doesn't matter. That's just going to equal 1 minus 0. Because when I plug 0 into this, it's just going to be 0. So my answer is a pretty little 1/4.